Ladies and gents, welcome back to the podcast. Today we're going to be talking about space and not the space that we associate with Elon Musk. We're going to be talking a little bit about spatial technology with Pablo and SLAMcore. So Pablo's CTO of a company called SLAMcore. He's going to give us some seriously good context into them and the algorithms that make up spatial technology, robots, drones, and they can actually understand the space that's around them. So, is that an all right intro, Pablo? You
Yeah,
good?
I
Nice to
think
meet you.
that's good. Yeah, nice talking to you, Elliot. Thanks for the
Good.
invitation to join the podcast.
Pleasure. Pleasure. Give us a little bit of a background into the man Pablo and your background. That'll set the scene.
Yeah, so my background, I originally come from Madrid, Spain. So basically, after kind of unsuccessful career in football and basketball, I decided to to do a PhD in robotics.
Okay. I can
So
see the tie,
Yeah,
actually.
I did actually. Well, first I studied kind of in Spain. It's called telecommunications engineering, which is a mix of electronics, electrical engineering, and a bit of computer science. And
Yeah.
then once I finished, I was always kind of interested into working on technology and working on engineering to help people and improve the quality of life of people in general. So I went to Sweden. I spent 1 year doing a master and doing research in biomedical engineering, a bit
Okay.
of medical imaging, signal processing, biomechanics, and then got back to Spain to the uni where I studied in Madrid. Kind of my advisor proposed me like, oh, you like doing things for people. Why don't you work on a PhD thesis on visual SLAM for blind people, basically to provide for blind users to carry like a camera and in a way
Okay.
provide like a sort of a GPS but more accurate. And I said like, oh yeah, that sounds very cool. And I didn't know at the time many things about Islam. So that was more than 10 years ago. I think I I did start in 2008 and finish in 2011, something like that, my PhD. So the goal was okay, build 3D models of CT scale
Yep.
3D models, and then we can use those for navigation and give assistance to visual impaired users. Sort of you get something like it's centimeter accurate positioning rather than meters accurate like GPS, and also it helps you to detect obstacles and so forth and so on. So after that, I spent several years working in academia and different places, basically working in SLAM and computer vision, but different applications. So I spent 1 year in France working in SLAM, but in laparoscopy or colonoscopy, also to reconstruct in 3D polyps and then give a classification if this is good or bad. Then also went after that to the US, work on SLAM more for autonomous driving or autonomous drones.
Nice.
It's kind of very similar technology, but you can apply to many different verticals.
Yeah.
And then I moved to the UK in I think it was 2013, 14. Spent 2 years working in Toshiba Research in Cambridge, lovely city, lovely place. I was working on autonomous driving at the time, and that's sort of when in the computer vision field, people started to think, okay, oh yeah, this deep learning, what is this all about? This is
Yeah.
pretty cool. So I started to work more on deep learning for autonomous driving. And then after 2 years, I joined iRobot Corporation.
Yeah.
I was based in London, but the team was in the US, and I was working on the feature capabilities of the Roombas. So now they have very cool products like the Roomba. I think it's called i7 and S9 that you can tell the robot go and clean the kitchen. So I was working on this localization and mapping for being persistent across multiple runs. And then, I basically at the time, I think it was in end of 2017, something like that. I
Yeah.
knew some of those SLAMcore co-founders because I collaborated with Andrew Davison in particular, who is one of his professor at Imperial College
Yeah.
and very well known in the SLAM field. He told me about the SLAMcore, and it was very early days for the SLAMcore. The company is a spin out of Imperial College. It was created in 2016, but they didn't start hiring people until 2017.
Fine.
And then I decided to join them about 4 years ago. So I was one of the very early hires. When I joined, we were about like 5 people in a small office in Hammersmith.
Yeah.
And initially, I joined as head of research, and also like some of my tasks and the things that I've been working on at the company. On the one hand, it's helping to build a team, grow the company, and at the
Yeah.
same time helping to build the technology that we commercialize at the moment. And also as head of research, kind of supervising the long term research agenda of the company. About 1 year ago, at the start of the pandemic, I was appointed as CTO. So challenging because it's like, okay, now I have so much work to do. Also, I had a newborn, and there was like all this pandemic that we didn't know what was going on, and we had to work from home. But I accepted the challenge, and I'm still here. So
Just thankfully,
thankfully,
thankfully, you've really done the rounds, location wise and companies wise, moving around. I quite like that. That's probably accentuated, I guess, some of the learning and different environments that you've seen.
yeah, I think it's. I mean, well, in a way, it's one of the good things when I did the PhD in Spain. It's like they gave me like 3 months per year. I could go on an internship, fully paid, somewhere else in the world that would accept me to basically work for free on research. That basically gave me the opportunity to meet other people, understand
Yeah.
other points of view, and basically improve as a researcher. And then that's something that then professional as well in industry. I like changing places, live in different countries, and so
Nice.
far and so on. But now I've been in the UK. I think this is my 7th year in a row. So now I'm a little bit stable, I would say.
Good. Good. I must ask. I've actually done my first Joe Rogan here, if you like, where I've quickly Googled something. So I knew this offline anyway. I just wanted to have a quick Google. What is SLAM? Help us understand SLAM. That's quite consistent in some of your messaging.
Yeah. So SLAM stands for simultaneous localization and mapping. What it's all about is SLAM. It's kind of maybe few techniques or an area of research, basically, like it's for robots or any kind of sensor that has cameras, any moving sensor, basically, or robot
Yeah.
or an autonomous car, is basically to understand your position in the world. First, you track some landmarks in the space from which you can estimate your position, and then at
Yeah.
the same time you are mapping and creating this map from the world that you use to estimate your location in the
Okay.
space.
Okay.
So it sounds simple,
What?
but it's a bit more complicated than that. But
Trust me. No, I can imagine. I can imagine. I'm going to touch on that a little bit later because I've done a little bit of research into this previously, and no way near as close to you guys. Object mapping, heat sensitivity. I can imagine there's a number of different facets that probably make up how you build some of your models. But I'm keen to understand the SLAMcore offering. So
Mhm.
we understand SLAM. Let's understand SLAMcore. What do you
Yeah.
do as a business for your customers?
Yeah, basically, since Islam in a way it's complex and it's very broad. It depends also in the sensors that you choose for your particular robot or your autonomous car, and so far and so on. And also building the technology, building a SLAM system that works in a real application is challenging. It may take for a company a few years of development, considering
Wow.
that you can hire experts in SLAM, normally people that have spent many years of their careers working in industry, building the systems. Sometimes it's people also coming from academia. They normally have a PhD in SLAM, and then they move to industry. So finding those people, it's very challenging because there are not
Yeah.
so many available in the world. So
Yeah.
what SLAMcore does is basically what we provide to companies is an SDK, so SLAM SDK, targeting visual inertial sensors. So we partner with hardware companies that more or less the cameras that these companies sell, or the compute platforms are popular within the robotics industry. So it's like platforms that anyone can buy. And then we partner with these companies, and then we develop our SDK that supports a variety of sensors and a variety of compute platforms. So basically, we provide this SDK to companies, and we tell them, okay, well, I mean, all the headaches of SLAM, all your sensor calibration, all the money that you need to put in to invest into a SLAM team and develop this technology, that's gone. You can focus on your real application and what you want to do at the end of the day with your
Yeah.
robot, and we will take care of the calibration, the positioning, and mapping for you.
Okay.
So it simplifies lots of things for companies if they use our SDK.
And depending on the sensors, do you have to alter how you build your software?
Our software, it's modular in the sense that would put a lot of effort in trying to make the system modular to support different sensor configurations.
Okay.
Because we are a software company, but we appreciate that at the end of the day, hardware is also critical in
Yeah.
SLAM. But then instead of saying like, okay, let's build hardware plus software, we said, okay, let's focus on the software, support multiple platforms. That gives more chances for companies and users to decide what is going to be the sensor that they're going to use. So we primarily focus on cameras plus IMUs. So IMUs stand for inertial measurement units. Very cheap sensors. We have those days in our mobile phones. Basically, gives you accelerometer and gyroscope for rotation.
Yeah.
So we combine that information with information coming from cameras, which it's cameras are cheap these days to build these maps and provide localization. But then also we are experts in sensor fusion. At the end of the day, SLAM, it's sensor fusion. It's you get sensor readings, you combine those in a probabilistic way, and then you get your map and your localization. So in that sense, if someone says like, oh, I want to use lidar because it's a particular requirement in my industry,
Yeah.
we can also incorporate lidar into our system. Our SDK at the moment supports also wheel odometry, because many of the robotics applications, they are robots with wheels moving on a ground plane,
Yeah.
and the information from the wheels give you some extra information, which is very important to robustify the system.
Okay. Are you able to give us a couple of examples of where some of your software is being used in robots or drones? Maybe that listeners would understand, I guess, where it is being deployed.
Yeah, so for us, I think 2021. I think last year we started to roll out our SDK on a much wider base, and this year has been kind of for us all about commercial traction.
Okay.
So I'm the technical guy, I'm not the commercial. But yeah, anyway, I think at the moment we may have like about at least 100 companies at different stages of the commercial funnel, and some
Yeah.
companies waiting list to use the SDK. So we have a variety of companies using our system. Some of them relatively small companies, some of them startups using our technology for
Nice.
different applications like drones, last mile delivery,
Yeah.
warehouse robotics. There is a lot of warehouse robotics. And then we
Yeah.
have also some other projects a bit with more like bigger companies But yeah, some examples could be like last mile delivery, wheeled robots, robots in warehouses, drones, social robots. And those are some examples.
Nice. Where does some of the technical or software challenges come in doing what you do, building spatial technology? Where are the challenges?
So some of the challenges it's I guess flexibility. Some of the problems that there are in the industry, in the spatial AI, is like if particular company build a spatial AI technology, if they build that technology themselves, it will take them like a few years of development.
Hmm. Yep.
Basically, because the technology is complex, and sometimes they will focus on a particular application, like let's say maybe a robot vacuum cleaner or AR headset.
Yep.
Then, if that company then wants to apply the same SLAM technology to a different kind of robot or application, now you want to port it to a social robot or to a drone,
Yep.
it's quite complex. Most of the time, you will sort of start from scratch to build another SLAM framework for that application. And what we try to do is to be modular and flexible enough so that our SDK can be used across different applications, different robots without so many pain points and headaches. And then it's of course, robotics in general. I think robotics is it's hard. It's a challenging field because robots they need to operate in real life.
Yep.
The some of the successful robots that we have these days they operate only in very controlled conditions, but the world is dynamic. You have lighting changes, you have weather changes. Robots they need to operate out there, right? So
Yep.
it's also working. Islam has been a technology that has been in academia for many years already. I would say like maybe about 30 years.
Yep.
But there is a big difference between something that you do in academia that works in your benchmark, very limited benchmark most of the time, versus something that has to work 100% of the time out in the real world. Uh,
Yep.
in a way, some of the challenges are in the robotics industry is uncontrolled environments, dynamic environments. It shares some similarities with some of the challenges in autonomous driving, where there are lots of corner cases in the real world and uncontrolled scenarios.
Where do you think that breakthrough comes? Because if you've been in an academic setting for 30 years, as in SLAM as a collective, where does that breakthrough come where, in your opinion, where robots can, I guess, sustain in a dynamic environment or the real world, if you like?
The way I see it, we are at the beginning of the robotics revolution, if we want to call
Okay.
it that way. We do have some very successful examples in robotics about very cool products. Some examples are the robot vacuum cleaners, for example, Roombas from iRobot. Then we have like amazing robots like Spot from Boston Dynamics. We have AR headsets, AR VR headsets
Mm.
that they have a SLAM system, and at the moment they are very, very robust solutions. Uh, but then I guess there are some limitations about what these solutions may offer. For example,
Yeah.
at the end of the day, one of the I guess the most popular robot in terms of volume in consumer electronics, it's robot vacuum cleaners. There are still lots of problems like I have one at home and I use it on a weekly or almost daily basis. Some of the headaches is like your robot gets lost in the house, then you need to go somewhere in the house, find the robot, get it back to the base, and
Okay.
that's frustrating.
Yeah. Yeah.
or
Yeah.
or sometimes the robot may not understand, like, oh, this is I don't know, this is cable or these are clothes, and you don't want the robot to mess up with those things.
Yeah.
So
And
there's some limitations at the moment, but
yeah, the scary thing is that you're cleaning your house on a daily basis. That scares me.
No, probably that was a bit too
No,
much.
I'm kidding. Of course, I'm kidding. Will we or could we have a drone or robot takeover at some point?
Takeover? What do you mean? Rule the world or what?
Yeah, I probably. I don't mean it literally
Yeah.
as in rule the world.
Mhm.
I'm not terrified of that. Don't worry. But as in where they are so prevalent in our lives. Like you talk about quite a lot of support cases there. The vacuum cleaner, for example, that is such a good support case that facilitates us.
Yeah.
Last mile delivery aspects, and I'm sure there are so many use cases that are being built right now that I can't even comprehend. But I guess what I'm trying to understand is, where does that stop? Do we have everything that is going to be robotized around us, or is there a world that could happen like that?
Well, I think we're gonna see in the next few years, like we're gonna see an increase of robots in our daily lives. We are gonna see an increase of robots in our houses, but also in industry. We're gonna see like especially kind of for very mechanic jobs or automation, warehouses, logistics. I think we're going to see more robots taking over, but also at home now. I mean, it's kind of interesting because I have two small daughters. One is 3 years old, and the other one is 1 year old. They go to nursery, and last weekend we met with one of her friends.
Yeah,
We went to the house, and they have a robot vacuum cleaner, and then the children already, they are used to live with some robots within the house. Then they get
mm,
familiarized with those robots. They put the robots funny names or names that they like.
yeah,
In my house we have an Alexa as well, and my
yeah.
daughter, she's so good, she already talks to Alexa, asks for songs, things like that. So yeah, I think for new generations, it's gonna be like given already that in a way they know how to interact with robots. Whereas I think maybe my generation, some people get used to it, others may not. And then if we go like my mom's generation, I try to explain my mom, I don't know how many times, how to use Alexa or how to use road vacuum cleaner, but I haven't been very successful. Uh, and then people interact with the robots. So yeah, I think, as I said, we are sort of at the beginning of the robotics revolution, and in the next few years, I hope like we will have more robots in our houses that facilitate our daily lives. We're probably gonna have lawnmowers. I mean, we do have already mopping, vacuum cleaners. Maybe doing. I hate doing the laundry and then ironing. So I hope we will have robots to
I
do
hope
that.
so.
And also now with all COVID and pandemic, like
Mm,
robots that disinfect hospitals, houses. I think that are getting very popular. So one of the challenges in kind of in the industry, and also is part why SLAMcore is here, that then in a way, I've talked about many different robot applications and many robots. At the end, most of the robots, if you wanted to move autonomously, they need a SLAM system under the hood. What it doesn't make sense to me is that each of these robots, each of these companies, they develop their own internal localization and mapping solution. So then
yeah.
the map that your vacuum cleaner is using, it cannot be shared for your lawnmower robot or another robot that you have at home.
Okay.
So that's where SLAMcore, I think, we can help to build this localization and mapping ecosystem. So then
Okay.
our software can be used across many different robots. And at the end of the day, it's like all are using the same kind of map standard, if you want to call it, rather than everyone building
Yeah.
things on its own.
Let's go with map standard then, and you talk about I guess the hardware having SLAM under the hood. Help us understand a little bit more about the sensors that make up some of these robots, because little bit like I said earlier in the show, object mapping, sensitivity, you touch on lighting, actually moving a robot to a dynamic world. How are some of these sensors actually made up?
Yeah, so there are many things to consider when you choose your sensor combo for your
Okay.
particular robot. One is accuracy that you want to achieve, reliability, cost. If it's for consumer electronics, cost is important.
Yeah.
So depending on that, you choose from a variety of sensors. I guess the most standard sensors in robotics, we have cameras, we have IMU, we have wheel encoders, we have 2D lasers, 3D LiDAR. Then you may also have manipulators. That's how robots will interact physically with the world. So based on your application and your requirements, you will choose your sensor combination. Plus,
Gotcha.
also you need to choose the right compute for your application, because
Yeah.
maybe AR headset, for example, you require to be like very fast, very high frequency, because you are moving your head very fast. Same as, for example, a drone. And maybe you need like very kind of you need a real-time implementation, and you need like maybe a relatively expensive hardware. But then there could be other applications that you don't need that real-time capability,
Yeah.
and you can do it with a cheaper hardware, for example.
Nice. Okay.
So
So
it's a lot of hyper parameters that you need to decide when you're building a robot.
yeah, I guess it's reverse engineering. What do you actually want that, well, not what do you want that robot to do? What will that robot do? Encounter, come into contact with, drone obviously flying, and work backwards from that. Okay, understood. Help us understand a little bit more about your relationship with RealSense then. This is quite an interesting relationship. So help us understand a bit more about that.
Yeah, so with Intel RealSense, we partner with few hardware companies, but for us, it's like we want to kind of commercialize our SDK and use sensors that are widely available in the industry. So from that point of view, RealSense in the last few years, they have released very amazing cameras that are relatively cheap and have all sort of sensors that we need for our application. So the cameras, they have visible cameras that we use for tracking. They have depth cameras that we use for mapping purposes. They also have RGB sensor that normally we use RGB for perception related deep learning capabilities for semantics in understanding. And they have also IMU, all
Okay.
hardware synchronized in a single chip at a
Yeah.
relatively low cost. So that's very good for us. And then also companies, most of the robotics companies that you may talk to, most of them they have already some RealSense cameras. So we partner with Intel, yes, basically to commercialize our solutions supporting the cameras, and they
Yeah.
keep on releasing new cameras, new sensors that we would like to support in the future. We are
Nice.
in close collaboration with them.
Okay. What's an IMU? I've
And
heard you mention
IMU,
that a
yeah, it's
couple of
a
times.
inertial measurement unit.
Okay.
So that's what you have in your phone, at least. When you rotate your phone, that what is used to, at least the gyroscope, to rotate your screen.
Okay.
Or any
Okay.
augmented reality that you do in your phone, it will be probably using the IMU.
Nice. Okay. Um, you're the technical guy. You don't do the commercials. Understand that.
Well, you can
Where's
have me on the commercials as well, but
fine?
you get
Okay.
more.
There's permission. Where's next for SLAMcore? You've given us 30 solid minutes on drones, robots, and what's under the hood. But where's next for SLAMcore and the business? This RealSense collaboration, I think will hopefully really help the business. But where else do you see yourselves heading?
Yeah, so I think for us in the next few months and next year, all what it's going to be about is about scaling. So this year we're getting some commercial traction. We already have had some design wins with some important companies that are using our solution now, sort of at a prototype stage. But then there is kind of like a commercialization phase
Yeah,
that we are getting into. And it's about the scaling in the sense to scale the team, grow the team, so we can collaborate and provide solutions to many more companies, and
okay,
also to work in our roadmap and facilitate, support more sensors, support different compute platforms. I said like we are supporting in our SDK at the moment stereo camera,
yeah,
but there are many other applications that customers are looking into single camera. Single camera is more challenging and it's less robust, but of course it's cheaper. Or multi-camera systems because
okay,
you will get more robust solutions. Or also LiDAR integration because in some industries, you may want to use a LiDAR for safety reasons, for example. So
yeah,
it's about expanding the features that we have in our SDK
nice.
that will enable us to collaborate and help more companies in our journey.
Nice. And the SDK traveled 1 million kilometers. I saw really recently you hit that milestone. So here's to the next 1 million.
Yeah, hopefully, I mean, we can have like close to 1 million of kilometers per day in the next future.
Good.
That's
Yeah,
the
nice.
goal.
Good. Um, so you talk about scaling a team. Help us understand a little bit about what you're looking for. For people listening, just help us understand that part.
Yeah. So in terms of what I talk about scaling the team, basically I'm talking like kind of mid horizon. At the moment, we do have like some openings. I think 1 or 2 openings in our website, but I think in the next few months we will have to scale the team. Basically, we need to add more people for marketing, sales, and commercial because most we are like about 30 people and the core most of the people come from a technical background,
Yeah.
so we got this far with a very little number of people working in marketing, commercial, and sales.
Yeah.
Then we do also need to add more people into product team, basically people that will collaborate with all these companies that they want to work with us, and we can give them support, troubleshooting, work on some features that these companies may be asking, and basically very good. We do have very good engineers and researchers, but yeah, adding more good
Always a
engineers to the
bonus.
team. So we have a bit of a mix in terms of technical skills because of the challenges of implementing the SLAM in real applications. So we normally look for very talented C++ engineers
Yeah.
that they have expertise running spatial AI solutions on embedded hardware, running things very fast, that they know how to optimize things, and also people that they have understanding either in calibration of visual inertial sensors or robotics or SLAM mapping. And also we have a small team at the moment, which is more, they are working more at the intersection between deep learning and SLAM and how to get best of both worlds. So also, yeah, we're looking more into solutions that will combine also deep learning within the SLAM framework as
Okay.
well.
Largely, we're engineering focused. So, embedded engineers, low level engineers, come and have a chat with Pablo, some of the team at SLAMcore. If anyone else catches this, product sales, marketing related, then of course, reach out to the guys and girls at SLAMcore if you like what you hear. Pablo, a massive thanks for joining us. Some awesome insights into what happens under the hood on some of our favorite, if you like, applications or day-to-days and what we do, or what surrounds us, if you like. So thanks for those insights.
Yeah, thank you very much. Also, I encourage everyone that wants to learn a little bit more about SLAM and what we are doing. We do normally write blogs on a frequent basis. So if you go to our website, SLAMcore.com, you'll be able to see the blogs, also careers, and you can learn more about what we're up to.
And below as well. So if we can all share, like it, show our friends who love robotics, that would be massively appreciated. And huge love from everyone at Engineers. And big thanks, Pablo.
Thank you very much, Elliot.
Absolute pleasure. See you soon. Hey guys, thanks for watching this episode. Massively appreciate you listening and checking in with us. If you want to find out more about us and what we're doing, please check us out on social media. What we're trying to do at Enginears is build a community to drive knowledge sharing and experiences. On Twitter, we can be found Enginears.io. It's no underscore. We've also got a website, which is enginears.io. These links will all be posted in the description. Any feedback and comments are massively appreciated. We're always looking to improve on where we can. Thanks, guys.